Okay, I am now about to start working some gas law problems for you guys. And I'm going to be working with my nice silver Sharpie. Can you see this? Yeah. Remember, the first thing that we do is we write our knowns and our unknowns, right? We always make this chart. Ms. Rosinski gives us points for making this chart, and she takes points away if we don't make this chart. Okay, what are our knowns? We see 2.0 grams of water. We see that we start with 1 liter. So that's our first volume. We started with it. 1 liter. We start with STP. STP is our starting temperature and pressure. That means 1 atmosphere and 0 degrees Celsius. And 0 degrees Celsius, what do we do with temperature? The first thing we always do, we always convert to Kelvin. Okay? We add 273. Please note, it is not degrees Kelvin, it is just Kelvin. It is not degrees Kelvin, it is just Kelvin. Okay, degrees Celsius or Kelvin, not degrees Kelvin. That is wrong. Degrees Kelvin is wrong, and I will take off points for that. Just write Kelvin. Okay, so we have a starting pressure, a starting volume, a starting temperature. We have a starting mass. And they also say that we're going to end with, end, that's a 2 for ending. We're going to end with 3.0 liters of our water. We end with 3 liters of our gas, and we end at a pressure of 4 atmospheres. So we want to know our final temperature. Once we have made our chart of our knowns and our unknowns, we can decide, okay, which equation am I going to use? And how do we decide which equation we're going to use? We look at what we're doing in this problem. We have initials and we have finals, and when we do any gas law problem, where we have a gas's conditions changing, we use, and here is where we write the formula for the combined gas law, right? And we write the formula because Ms. Rosinski gives us points for knowing the formula, all right? P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay? That is our formula. Remember where we got that from? We had P1 V1 equals N1 R T1, and we had P2 V2 equals N2 R T2, and we divided them out, and our R is a constant, so it canceled. And then they just did some algebra to end up going from here to there, okay? That's all they did, just some algebra. Algebra should not be scary at this point for you guys. Okay, so now we have to rearrange this formula to get solving for T2. Okay, so if we're going to get T2 by itself, then we're going to multiply both sides by T2. Now, if you want to show me this algebra, you definitely can. Okay? I'm not going to take points off if you don't show your algebra, but you should definitely strongly consider showing your algebra, because it will keep you from messing up, okay? If you mess up your algebra, I'm going to take points off if you give me a final rearranged formula that's wrong. So make sure you do your algebra right, even if you don't show it to me, because in the end, I'm still going to check that you got a final equation that is correct. Okay, so we multiplied both sides by T2. We can also multiply both sides by N1 T1 to get that out of our denominator. Okay, so T2 equals P2, B2, N1, T1 over into, and then we can divide both sides by P1, V1. Okay, and here's our equation that we're going to use. Now, the last thing that we have to figure out is number of moles, okay? And, I guess the problem didn't give us number of moles, so I'm going to say this equals N1. I'm just going to make one up now, okay? I'm making it up. It wasn't written on problem. I'm making it up right now. N2 is going to be 3 grams of gaseous water, okay? So this says gas in parentheses, that right there. Sorry about that. All right. So what do we do now? Is everything ready where we can plug it in directly? Not quite, okay? We have grams here, and we have to plug in moles. This N stands for moles, remember. So how do we turn grams into moles? We have to use molar mass. So we start with what we have, 2 grams of water, okay? And we look at our periodic table to figure out that there are 18.02 grams of water and 1 mole of water, okay? And that means our grams are going to cancel, and we end up with moles, which means we know we did it right. And when I put that in my calculator, 2 divided by 18.02, I get 0.111 moles of water, okay? And when I do that for 3 grams, 18.02 grams of water. 3 divided by 18.02, we get 0.166 moles of water. Okay? So now I need a new sheet of paper. So now what do we do? This is our real N1, and this is our N2. Okay? Now we can really plug things in. T2 equals... Sorry about that. If you noticed a shift on the camera, it's because my camera started falling because I don't have an actual tripod and I've kind of jerry-rigged something up. But anyway, T2 equals P2, which was 4 atmospheres, times V2, which is 3 liters, times N1, which was 0.111 moles, times P1, which is 273 Kelvin, divided by N2, which is 0.166 moles, times P1, which is 1 atmosphere, times V1, which was 1 liter. And when we put 4 times 3 times 0.111 times 273 divided by 0.166 into our calculator, we get T2 equals a really big number. And this is where we say, that looks like a really highly unlikely temperature. Let me double check that I canceled all my units correctly. Moles cancel with moles. Liters cancels with liters. Atmospheres with atmospheres, and I'm left with Kelvin on top. I must have done it right. So I'm not going to worry about it. 2191. Kelvin is my answer.